So for those of you who don't know, and I think I met everybody, my name is Dmitry Polyakovsky. I work at Oracle. I'm a big, long-time Redis nerd, and I'm very excited about Valkey. And I'm going to talk about how to build Valkey modules in a language called Rust. So, as I said, I work at Oracle. I'm the technical lead for Oracle caching service. It's managed Redis. We will be offering Valkey in the near future. But for now, if anybody's interested, we actually have a pretty generous free tier. Just log in, launch a managed Redis cluster. We call them sharded and non-sharded clusters. Okay. So actually, I'm very curious, what do people use Redis Valkey for? So how many people use it as a cache? Job queue, session store, any other interesting use cases? I don't know, for real-time analytics, anybody? Okay. As I figure, for this being a pretty advanced audience, people use it for just different things. So I'm going to talk about modules, why I think modules are cool, how to build modules in Rust, and how to test them. So modules were first introduced in 2017 with Redis 4, and they allowed you to add extra features. So there were some popular modules for JSON, graph, time series. And the way I think about modules, it's kind of like, this is a famous painting of the Tower of Babel, and it's the story of how people try to build a tower to reach the sky, and God punished them by making them speak different languages. And this painting actually hangs here in Vienna in a museum. But it's a good analogy for some software projects I worked on that just became too ambitious, and different people involved in a project simply had different expectations. They were speaking different languages. And with modules, you can keep your core simple, meet the majority of use cases, and then people who need extra special functionality can implement it separately and run it themselves. And at some point, if a feature becomes extremely popular, then you can make a decision to pull it into the core, into the main project. But once you pull something into the main project, it's very difficult to remove it later. So when it comes to modules, I think there are two categories of use cases. One is the developer use case, basically different data types, different commands, but there's also a DevOps use case, and that's pretty much been my life for the last 3 years, where I've been building and maintaining the Oracle Cloud caching service. I very much worry about how do I run my Redis servers on behalf of my customers. But prior to that, I was a developer using Redis, so I very much cared about, gee, wouldn't it be cool if I could store JSON in Redis or Valkey? First of all, you don't have to use Rust, even though the title of my presentation, Building Modules in Rust, you don't have to use it. Some people are very passionate about building stuff in C, and there is a, I see some people are shaking their heads in this direction, and some people are shaking heads in this direction. But the beauty is, we don't have to fight. Some people can do it in C, some people can do it in Rust. But if you do want to do it in C, there are some examples on that to help you with that. So here's the Valkey code. And the files you're going to want to look at is, first of all, Valkey module.h. It's over 2,000 lines, so we are not going to be reviewing that in depth. And if you think that file is large, you can also look at module.c. And that file is 13,000 lines of code, so we will also not be reviewing that in depth. But if you're interested in learning how to build modules in C, a good place to get started is source modules folder. And there you have some really nice examples how to do it. And here's, for example, one that was contributed by our friends at Amazon. Madeline, I suspect you personally wrote that code, or somebody you know. And this basically allows you to build some commands to do ACL functionality. So to make it actually even simpler, I built this module1.c. It's a module called module1. So to build a module in C, you have to have this onload. You pass the context, and you pass arguments as strings. Here I'm actually not using arguments, so I'm just using this Valkey module not used. You then have to initialize the module, so I'm initializing, specifying its name, the context, and specifying the API version. And after that, I'm calling this create command, which in turn calls this piece of code. So I created a command called hello, and it returns world1. I love it. Question, go ahead.
Yeah. So I have some.
Can you grab a mic?
What? Mic.
Is there a microphone?
Thank you. Is this on? Good.
I have some experience writing modules, specifically in Redis using C, and I'm thinking about making the transition. But just looking at this example, my code is going to break. For example, I see here Valkey module string, which I'm used to Redis module string. So I'm not sure if the header file had taken that into account or not, if there's maybe a type def or good. Okay. All right. So basically, the former Redis module API is fully supported. Okay. Great.
So backwards compatibility is a priority.
Thank you.
Yeah, so you will be able to run. And also, I also wanted to be, if you build a module using the Valkey module REST SDK, which I'll demo later, you should be able to run it on Redis as well. So, okay, so good question. All right, so back to this module. Okay, so again, doesn't do very much, but if we jump to, actually, see, I'll show you how I'm starting my Valkey process. So I create a file called modules.conf, and I specify this load module command a bunch of times, and you can see there's a lot of modules, either the ones provided with the Valkey code itself in C, and later I'm going to go into the ones that are provided with the Valkey module RS, the examples. And to run it, I'm actually able to run it from VS Code here, and I will give you a link later if you're interested in debugging Valkey in VS Code, how to do that. So anyway, so right now I'm just running Valkey in VS Code. So I will jump into Valkey CLI, and you can see here, this is the modules that I've loaded. So to exercise this new module 1, I'm going to say, let's see, module 1.hello. Oops. And it says world 1. So it works. Not very interesting. Okay. So another piece of code you might want to look at is test modules. That's a bunch of tests, as you can guess from the name. And there's a lot of really useful code samples, so we're not going to be reviewing them all for obvious reasons, but if you're interested in building modules in C, this is where you'd want to get started. So if you go way down here in tests, yep, there's a test for modules. Okay. So we talked about the onload, we talked about the init, create command, not used, that's if you're not using particular arguments. And there's also codes Valkey module OK and Valkey module err. And in Redis, they're just called Redis module OK and Redis module err. And also, it being C, you're going to have to make some small changes to a make file. So pretty easy to do. Just copy and paste what they give you here in examples. So I created here module 1xo, and that's how I compile it. If you're interested in doing that in depth, you can check out this blog post I wrote a few months ago on Valkey website, Valkey module 101. I literally give you the code samples that I just showed. Okay, are there any questions so far? Okay, again, feel free to just anytime ask questions, and we'll get you the microphone. But now let's get to the kind of the primary purpose of my presentation is how do we build modules in Rust? First of all, how many people have Rust experience? A year of Rust experience? More than that? Okay, so beginner audience in Rust. Okay, I will make sure to cover certain Rust-specific topics. Well, why should we use Rust? To me, the biggest advantage of using Rust is memory safety and security. So if you're working in any kind of a regulated environment, or if you're building software that will be used by a government agency, literally just a few weeks ago, I think, the US government kind of issued guidelines for safe computing, and they emphasized memory safety as one of the big causes of security vulnerabilities. So if you have to go through a kind of compliance process, if you have C code, you might get a little bit more scrutiny, versus if you have Rust code, it will help you. And it will help you write better safe code and prevent you from making a mistake, but it'll also help you get through this regulatory hurdle. And if you want to write Rust code that works with Valkey, that's where the Rust Valkey SDK comes in. And in addition to that, there's Crate, which is a huge collection of various libraries. It's like Maven for Java, or let's see, bundler and jumps for Ruby or Node.js. Again, all these languages have their own tools for dependency management and build. Crates has a ton of different libraries, and there's a nice tool called Cargo that comes with Rust that really allows you to very easily add new dependency, use them for testing, use them to build. So really nice developer experience and boosts your productivity. So let's jump into this SDK. So this SDK is forked from Rust module SDK, so we give them credit in the notes, but most of the references to Redis have been replaced for external. Actually, I think at this point, all external commands, all external calls have been replaced. So if you used to say Redis module, now you say Valkey module. Internally, there are still a few references. I'm kind of working through it. So just give me a little bit of time and I'll get it all replaced. Yes, there's a question.
Was the process of creating the module API for Rust from the original header file for the Redis module, was that being done automatically using some utility?
So I just included Redis module 8 header file here. At some point, we will rename it to Valkey module.h. So I just moved the header file.
Okay, so using the original header file,
yes.
and Rust can assume those function exists?
Rust will use the header file functions, yes. And you have a question? Oh.
Well, I don't know if this is exactly your question, but I think we use bindgen, don't we, to generate all of the stuff? So bindgen generates a bunch of...
There's a cargo crate called bindgen. Sorry,
Yes.
go ahead.
Yeah, so the crate bindgen generates a bunch of wrappers, and then we call I think there's a second set. So Rust has two types of APIs. There's the unsafe and safe. So safe provides all the guarantees that Dmitry was talking about, memory safety. And then there's unsafe, which is not safe. You can do whatever you want. You can call C functions. So we basically wrap all of the, so bindgen generates the unsafe functions, and then we wrap them all with safe functions.
So this is the bindings I believe that this is automatically generated.
Correct.
Okay, so now the good place to start is also examples. So this crate, or this SDK, which is a crate, also provides this very full folder called examples, and inside there's a bunch of examples. So if you're just new to Rust, or if you're new to module development, this is a great place to start. This is where I started when I started building these things this year. So here's a really simple module. Again, the code is similar, but a little different than what we saw in the C example. But there's this thing called a macro. It's basically a Rust way of generating a bunch of boilerplate code for you. So I give a module a name, version, and I specify commands. So here's going to be a command to get current user and verify key access for the user. And this just calls these functions. So if you're not familiar with Rust code, it's big into functions. So to compile this, I just run cargo build, and then I can load this module. And if I go back to my Valkey code, I can see here that, again, you can see these are all examples, and you can load them all quite easily, but then it just becomes kind of difficult. So I selectively load some of the modules. So you can see here this libackle dylib, that is on Mac OS what the Rust code will compile to. On Linux, it will compile to .so file, and it's going to be a DLL on Windows. So I'm loading this module, libackle. So let's jump into, and you can actually see it here. It's not helloackle. Helloackle is the C module, but libackle is right here. And C modules and Rust modules can coexist side by side on the same Redis or Valkey process. So to use this new module functionality, I'm going to call the, let's see, get current user command. Again, custom command, default, yes. And then the other command is called, let's see, verify key access for user. Now this command requires arguments. So, if we look at the code here, we can see that it requires arguments user and key. So great. So let's say I want to check default and whether default user can access key foo. Now the key foo doesn't exist, but it doesn't matter because what this code is doing is it's using actually behind the scenes the context and it just calls this function, and that's how I can verify whether user default can access key foo. And the same thing for key bar. Now, if I were to implement ACL or access control list, ACL, and prevent user default from accessing keys, then I would get a false. And if I, for example, if I make a mistake and provide a wrong user, then I get an error that says, hey, this user doesn't exist. So if I grab that error, I can just like literally grep for it, and I can see where it's coming from. And if you're interested in learning more, you can just kind of like do some, spelunking and explore the code. Okay, so we talked a little about SDK. So we talked about the Valkey. So there's a Valkey module, which is different than, just keep in mind that Valkey underscore module is not the same as Valkey underscore module exclamation, because Valkey underscore module exclamation is the macro versus Valkey module is just the name of the module. So it was a little confusing at first. And then there's, like I said, multiple commands that get created. So this is again, examples are a great place to start. Another great place to start is tests. So in Rust, there's 3 different kinds of tests. One is called unit tests, obvious what they do. The other one is integration tests. And the third one is documentation tests. They are less important, but they actually basically check to make sure that if you provide documentation examples, that the syntax and other stuff is correct. So useful if you're publishing a library. But these are the integration tests. So these integration tests, and I'm going to actually run them to show you how they work. I wrote a bash script here to do it, but you can see what I'm doing is actually I'm starting Valkey process on different ports, and I'm loading modules, and they're not slow. See, they're done in a matter of seconds, but they're not the speed of unit tests. Let's put it that way, where they'll take a fraction of a second. But the great thing about them is they will start the process and they will exercise the command, so just like your users will. So you can, provide parameters, arguments that your commands expect. You can do validation in your commands that require a certain number of arguments and certain data types for those arguments. And your code will respond with appropriate errors. And in your integration test, you can actually check whether the right response is given. So it's a very good way to test kind of like external functionality, like integration tests, right? You test from the outside. Now, I'm also a big fan of unit tests because unit tests allow me to do all kinds of scenarios for, let's say, negative testing. I can pass in valid parameters and I can test them much faster. And I also don't need to have the Valkey process running, which can be, with some CI/CD pipelines, you may not have that flexibility to actually have like a full-blown operating system and to launch this. So that is a little bit harder, and I'm working on solving that. But I'll show you some examples here in, let me find that code, excuse me, CFG test. Yeah, so Rust has this whole CFG thing, and here you can see that this is a special test portion of the code. So in other languages, you're often encouraged to have your, let's say in Java, you would have a Dmitry.java class, and in a separate folder structure in tests, you would have, Dmitry test.java, right? Well, in Rust, the recommendation and the common practice is that the unit tests will live next to or below the actual functional code, but the integration tests do live in that separate tree. So here you can see that I have, let's see, yeah, so tests. But again, the source code is business logic and unit tests, and the test path tree is where the integration tests live. So you can, but here I'm looking at the unit test, which I wrapped with a CFG test, and yeah, I can write unit tests, but it's a little tricky to model certain things. For example, very often in your module, you're going to use the context to do all kinds of things. Well, I'll show you later, you can create a dummy context, but it doesn't do anything. So one of the things I'm working on is kind of like simplifying that process and making it easier in the SDK to just create context and either mocking or faking certain behaviors. Because let's say you're going to use context to get server info or to just get other information to maybe discover whether your server is a primary or replica, and then you want to behave differently in your module to do different things. So if you could have a mock or fake context to do that, That would significantly improve it, and you'll be able to use unit tests to test your business logic, versus right now, I'm relying a lot on integration tests to, basically I have just basically a code that basically starts Redis server, so a Valkey server, and then starts another one, makes that a replica, and then different business logic is exercised. But I'm testing it through integration tests. I want to do more through unit tests. Anyway, let's see, it's back to this, okay. Oh, so another thing in this SDK, there's actually two, I guess you can call them sub-crates. Basically, if you look at the code, so here you have examples, then you have source, that's where the code is. But then there is this Valkey module RS macros and Valkey module RS macros internals. And if you go to crates.io, you will see that there are three separate crates there. But they live in one GitHub repo. And I'm following a pattern that was established by the Redis module SDK crate. So at some point, maybe we'll decide to pull these out. I'm open to feedback of what people think would work best long-term. But when I forked this Valkey module RS from the Redis module RS, I just kind of wanted to stick to the current pattern to make it easier for people who were using the previous library to move to the new one, and to just kind of also keep the scope of work manageable. Okay, so we talked about these crates. Cool. Again, so those who are not familiar with Cargo, as I said, it's a great tool for package management, but also build. So you can run Cargo build, Cargo test, Cargo format is really nice, just formats your code. So you don't have to have these like super long lines. There are certain just recommendations that Cargo uses. Okay, so when you build code, there's two processes. You can build it for debug or for release. So obviously for development, I'm using debug. But if you look at here you see debug, and inside, if you go to debug, you'll find examples, and inside examples, you find a whole bunch of files, and that's what you need to, at the end of the day, get into your Redis or Valkey process. So if you look in my file here, so you can see that I'm just referencing these, and again, the naming convention, so the file name is acl.rs, but the library is actually libacl.dylib. dylib because I'm compiling on Mac. If you're doing it on Linux, you'll have .so file. But again, when you load it into Redis, it loads it. Okay, we talked a lot about testing. All right, so let me show you a demo of a library that I'm building, and it's based on a lot of the stuff that I'm doing in my day job. As I said, we're running a bunch of Redis servers. In the future, we'll be offering Valkey, and we want to make it easier to manage them at scale. At some point in the future, we'll probably be building some customer features, maybe new functionality, don't know yet. And so if I look in my Rust mode.rs, that is my Rust module, and by the way, it's on GitHub. I'll give you guys a link if you're interested in checking out this code. So as all Rust modules, or as all Rust software, you start with lib.rs. Because it's a library. If you were building just an application, you would have a main.rs file. But here it's a library I'm not going to be running it on its own. I'll be running it as part of something else. So I have lib.rs. And again, you can see a lot of similarities here. I have the same Valkey module macro. I give it a name, Rust mod, and I specify commands. So I created a bunch of commands here to show different things. So here I created a command called hello, kind of very similar to the one we saw in C. And I actually created several hello commands. So sometimes when you build a command, it essentially becomes part of your module API, and then you have to change the API. So for backwards compatibility, you still want to keep the old one working. So it's very easy. So all you basically do is you just create a new one, but you reference the same Rust function. On the other hand, sometimes you have to maybe add a little functionality. So here I created a hello2. So and in this case, hello2 just calls hello. But hypothetically, I could add more logic here, right? So, but, they're very simple commands. Again, demoware, right? Rust mod.hello. Okay, it says world. But if we look at the code, you can see here that I'm actually doing some checking. I say that if arguments lang is 1, now args always includes the command name as the very first argument. So argslan1 means there's no arguments. Yes. Love questions, and everybody else, feel free to ask.
A question about runtime debugging.
Yes.
Suppose I want to attach a debugger to my Valkey process.
You can do it in VS Code,
Yeah.
and it'll actually go into the Rust code as well.
Suppose I have both my Rust module source code and I have my Valkey built on my machine with its source code. Would the debugger be able to step in and show me the source code for both Rust and C?
I will crash my process right now to show you how it works. By the way, if you're interested in using VS Code to debug stuff, there's an article here by one of the Amazon engineers. Oh, sorry, not this one. Visual Studio Code setup for Redis. It's a few years old, but it still works. You just have to like reference, change it to Valkey server versus Redis server, but yes, so let me kind of show you. There's actually one thing I've been wanting to fix in the SDK, and let's see, I have a to-do for it.
Spelled to do wrong.
Thank you. Okay, it's in, yes, so there's a command that fails, and it's test helper. Okay, so if I run this command right now, oh, excuse me, I need to load this module, so give me a second. Modules dot. Right. Oh, sorry, I'm in the wrong repo here. Let me go to Valkey. Yeah, here's Valkey and helper. Oh yeah, it's this one. I could reload module without restarting Redis or Valkey, by the way, with just module load command, but it's easier to just do it. Okay, so, okay, cool. So let's see. Okay, so it's giving me this, and now it crashes. And you can see here that I'm actually, so this is VS Code running Valkey server, but it actually stepped into a specific crate that I'm using. I have not had a chance to debug it. So I think that answers the question that yes, you can use VS Code at least to debug Valkey server, and you can actually use it to debug the Valkey module written in C. But here you can see that it'll step into the Rust as well.
And you can confirm that the line on which... Okay, so... And from your experience and your knowledge of this module, you can confirm that where we're at is exactly where you would have expected the crash to occur. So there's no...
This because I have not figured out why it's crashing here. Because what happens is it works the first time and then it crashes the second time. So, and it's happening in this mem.chr crate. So I just need to like read the documentation and figure out why it doesn't work and fix it. So, but it's kind of handy to be able to debug both. And I completely understand your question that yes, you don't want, you want to be able to like have your Rust code, which is running inside Redis C process, but how do you debug it?
Okay.
So let me restart my Valkey server. Okay, so let's go back to the demo of my Rust mod module, which is right here. Okay. So, so I have these really silly commands, hello, hello2, and hello3. Okay, let's do something a little bit more interesting. Sometimes you have to do, you have to execute several commands, modify several structures, and you can do it with, let's say, some kind of a pipelining. Libraries often do it for you, so as a developer, you're not even aware of what's happening under the hood. You don't know which Redis structures are getting used, or Valkey structures, but how can we do it a little bit better inside Valkey with a module? So here I created a very simple command called set get. And what does it do? It allows you to set a key and then reads the value of that key and returns it to you. What could be a practical example of this? So one of the things I've used Redis a lot for is job queuing, and there's some really nice libraries for that. And they basically use a lot of like sets, I mean, sort of sorted sets and lists and hash maps, data types under the hood. And if you write a library in one language, then somebody else comes along and says, oh, I want to use it in a different language. They have to essentially re-implement a lot of this functionality. So if this functionality were to be moved into a module, and Salvatore wanted to actually build a job queue module inside Redis or on top of Redis, that could be kind of like done once, and everybody could take advantage of it, and they wouldn't have to reinvent this functionality in different languages. So here I have an example of using two commands. One is set, one is get. And you can see here I'm doing some validation on the arguments. So I require at least 3 arguments. Again, the first one is always command name. So in reality, it's 2 arguments that I have to type in. And I grab one. Actually, first I take that args vector and I turn it into an iteration and I skip one. That's one of the nice Rust features. And then I use this next, and that function actually comes from the Rust SDK for Valkey. And so I grab key and value, and I perform a write operation using a high-level call, which is accessible from the context. And I say key value, so this is basically the set key value, very simple. And then I log something to a file just for debugging purposes. And then I perform a second operation using call to get that key, and I return it to the user. So let's run this command. So, oops. Rust mod, hello, yeah, this worked. Okay, so rust mod.set get. Again, I have to provide those arguments. So I say foo bar, and it returned me bar, and I can see now that there, oops, keys. So there's a key foo, and if I can read it, I get bar. So nothing super exciting, but I was able to do this operation in one command, and it behind the scenes, it did 2 things for me. Okay, let's do something a little bit more interesting. So what if instead of using call higher level API, I actually wanted to open the keys and operate on them? No problem. I build another command, set get to. So again, doing the same thing, validating the keys, validating the arguments, grabbing the key name and value. And now I'm open key as writable. So there's another functional to open key writable. I grab the string, and then I write to that string, and I write it to a log file that, hey, there was a response. And we can actually see this log messages in here. So you can see that, yep, see here, response set, response get. That was from the previous operation. So if now I do this set get to, so let's say do it foo1 bar 1. Okay, get foo1. Okay, so this did the same thing as before, but this time I did not use this call. I actually used a lower level API. And if you want to know more about it, Redis and Valkey have documentation that explains the differences. So it's a little bit more code to write, but sometimes you want that control. And I believe there actually are certain performance advantages in some situation to use the lower level API. Yes?
Yeah, that's correct. It's much more efficient to do the low-level APIs. You're going through the whole like command processing stack.
Yep.
And it'll also show up as a command too if you do command stats.
Oh, interesting. All right, cool.
You have to do, so the question was about replication. I'm not going to walk over there. Modules are required to handle replication themselves, so there's no difference between doing call or the low-level APIs with replication.
Yes.
You have to manually do the replication, and it will replicate it logically, so it will replicate the command.
Yes. And I don't have that working, by the way. And especially with my data type. So I'm about to show you a custom data type, which is kind of the next thing. And again, these are very boring demo examples. I assure you we're doing more interesting things at my day job, but it's a little bit confidential, so I didn't want to share it here. Plus, it's very specific to what my day job is. Anyway, so I created a new data type. I called it my data type. And it just holds the data, and it's just a string. And then I registered it. And I had to implement a few things here to do, for example, when RDB load and RDB save and when free. And that is where this unsafe code comes into play. And I was, so that, let me show you what I can do with it. So, and actually you can see here that it's calling it raw module from the SDK, and here it's calling the Redis module save string buffer, and So to use this custom data type, my data type, I created my set and my get. So, and I'm using the lower level API to open the key as writable, and then in the my get, I'm again using the open key, not open key writable, and I return the content. So basically, if there is no data and if the key doesn't exist, I just return nothing. So this is basically, I'm doing a match on if it's found, I will return the data. If it's not, I just return this. This is a Rust thing. It's just like an empty nothing thing. I don't forget what they call it. Anyway, so let's try to exercise my set and my get. So let's see, Rust mod.myGetFoo. Nothing. Okay. If we do my setFoo, it's telling me that, hey, you got to provide a value. Fine. So say bar. Cool. It said okay. And now if we do my getFoo, if I do getFoo, it's telling me wrong type. So I just created a custom data type that's essentially a string. But, you know, there could be other interesting custom data types. I will show you an example of a Bloom filter data type, which is a separate module being built by one of the engineers in Seattle, and that is using this SDK. Madeline, you look like you have a question or a comment.
No, I'm just very expressive.
Okay. Okay. Another really interesting thing that you can do with modules, you can configure them. So there are a couple of different ways I'm experimenting with configuring modules. So if you look at actually how I start this module in my Valkey code, right? Oops, sorry, wrong one. Yeah. So if here, you can see that I'm specifying my module in the same foo true 10. Okay, not very interesting, but let's see what it actually does. So if I go here and I say module list, okay, so there are the modules, right? This is, by the way, that Bloom filter module that I'll show you later. This is the test helper module, local, but here's the Rust mod. And there's arguments, foo, true 10, which are passed in when I loaded the module. That can be done either in a config file or when using module load command, you can specify them. But you can grab them in code and do things. So for example, here I have init, initialize method, which is run on init. And I create, it requires an array of Valkey string. The commands actually require a vector, but this is an array. So you can see here that I got config str, config bool, and config num. And I created these static variables here. And I am storing what I'm getting from the command line in config str, config bool, and config num. This difference here is that config string is just an option string, but config bool and num are atomic. Rust provides you those nice atomics, which is good. And here, I basically set them. So if I now want to access these config variables, to do it, I just build a command, and I called it config. So if I run rust mod.config, oops, you can see that I can look them up, and obviously, in reality, I would have business code that depends on these configurations. So you can easily change these configurations by reloading the module without the server restart by doing module unload and then reload, but that still takes a few seconds. And what I really want, I want to be able to change these kinds of configurations just via a command line. So for that, I created something else. I created a metadata variable here to hold a metadata, whatever I want, and it's just a hash map. So it's actually, so if I look here, again, I have to hit this unsave thing. So and it creates just a hash map new, so there's nothing there. And to access this hash, so again, so it's two different configurations. One are relatively static because I specified them, again, config string, config bool, and config num, and I can specify them during the module load process. And another one is extremely flexible and dynamic and a little bit more dangerous because of that, because you can write anything you want. And so to do that, I created a command called get metadata and set metadata. So if I run it right now, rust mode config get metadata, oops, there's nothing there. But I can set metadata, I can make it anything I want. So it's really flexible and, like I said, a little dangerous. So I can say name Dmitry and city Vienna. And now if I do a get metadata, I see it there. So think of a situation where you are rolling out a particular new feature and you want to feature flag it to a very specific Redis server or Valkey server running maybe for a specific customer. Or maybe you want to put some kind of a metadata in there so you can easily look at this process and know which customer it belongs to. You can use that. And like I said, this can be done without server restart and without loading and unloading module. So I could turn it on like at runtime. Yes.
I think that at least with one of the recent module API, you have the ability to extend the native configuration.
Yes.
So if we're discussing module level configuration, it might be more appropriate to use the built-in configuration.
Yes, but the problem is then it'll show up in a config get operation. And I'm not sure I want it. Then the users will see it. Like this approach, it's completely hidden, but you're correct. You can use the config APIs.
Okay.
So, and I'm actually kind of going back and forth on how I want to implement it. Like in this way, first of all, the commands will be not accessible to the customer because we're going to restrict them to the users because they'll be restricted with the ACL. And using the special administrative user, we will be able to run them and modify this metadata as we see fit. But yes, it is more complicated than what you're suggesting, than what's already there. So we might end up going with kind of like the recommended approach. If you can tell me how to hide it, like if I could hide it from a config get star, that would be awesome. Sorry? My customers like config get. Yes, the comment was to rename config get or to restrict customers from running config get. So,
I also had a question. So if you go back to the code for a second, the lib.rs, you very quickly went over the fact that the hash map was unsafe, but why was it unsafe in lib.rs? I think it was in lib, or yeah, that
Yes,
one. Why is that in
and,
an unsafe block? That looks like all safe code.
Yes, it is unsafe code, and it's because of the option string. Because of this. I don't remember how to work exactly why right now, but I am experimenting. I don't like unsafe code, so I'm experimenting with ways to make it not unsafe. And yes, you're absolutely right that the default recommended config way of setting doesn't have the same complexity and unsafeness.
Okay.
I acknowledge the benefit of the approach you're suggesting. I'm just showing people the options. All right, let's see. I think we talked about, okay, so we talked about ACLs, how we can use that to restrict access to the special commands. We talked about data types. Oh, event handlers. So event handlers is also kind of cool. So you can fire them on different things. So for example, this one fires on loading. This one actually fires on config change. So if I go to my Valkey server and say config set max memory, okay, it happened, but then in my log file here, I can see that, yep, config change event handler. So it could be useful. Maybe you want to be notified or something when certain configurations are done. Again, and another interesting one that I like is a cron event handler. So if you go to cron event handler, so Redis, so Valkey has a cron process, server cron, runs by default 10 times a second. You probably don't want to run things every 100 milliseconds, but you could build something like this, where you basically just create a hash map and you have certain functions, and you have a cron running inside Redis. So again, foo and bar, very complicated, but this is what's actually generating all this gibberish logs output here. And you can see, if you look closely, you'll see that it's every 15 seconds and every 30 seconds. More complicated than running a simple Linux cron tab and running a bash script or a Python script, But what's cool about it is that, again, combining it with these configuration settings, I can actually maybe start and stop these things. I can modify I can just disable one of these cron processes and do it without server restart, which is really important when you're running lots and lots of Redis servers or Valkey servers for other people. Okay, configuration, we talked about that. So again, there's two approaches, right? There's just simple module load, and that is very useful when you kind of have certain set of predefined options, and you just, as a developer, you build a module, and you want your DevOps engineers to be able to like maybe turn on and off certain features, or maybe it's provide some kind of a, maybe some module is going to send notifications, and you just want to specify the exact URL to which it's going to make a HTTP request or whatever. But if you really want a lot more flexibility, you could use either the config API or this more complicated and slightly dangerous metadata that I did. All right, questions? Ooh, perfect, 2:11, right on time. Okay, oh, shoot, testing, I forgot about it. Oh, actually, we talked a lot about testing already. So if you look at the Valkey REST SDK, you'll see I did a PR recently where I implemented a way to use system allocator, and that is done via, so here I'll show you in here. If you in your cargo file, you will specify enable system alloc. It's going to enable system allocation, but if you look at the crate itself in the alloc file, so by default, it will want to use this Valkey allocator, Valkey alloc. It still references Redis, trust me, it's, at some point we'll change it. But if you pass this enable system alloc feature, it's going to use standard system alloc, which is pretty useful for testing, but not for production. Okay, let's see, we also talked a lot about wrong arity. Again, really nice to be able to just like make sure people provide the right number of arguments. Just do that check up front. And then you can actually do checks for, hey, is this the right data type? Is this numeric or string or Boolean? And Valkey itself actually has TCL tests, so you can use those. And I talked about unit testing, how what I'm really trying to do is trying to like take that function, the command function, and make it smaller, and then push the business logic into more standalone REST functions. And then as long as I don't need any Valkey specific stuff there, I can just unit test them. And debugging, showed you VS Code. Okay, bunch of really useful references. That was actually a very useful video at 2019 RedisConf that kind of inspired me to try Rust. I've watched it numerous times. And there's references to, oh, sorry, there's also a nice library that created an engineer at AWS is building to do Bloom filters. So if you're interested in trying out Bloom filters, check it out. I actually have it loaded right now, but I'm out of time, so I can't demo it right now. Other questions? Okay, thank you very much.